So we're going to talk about graphs now, and the graphs we talk about are not the ones you think about where we draw them on the XY axis. These are graphs which consist of edges represented by lines and vertices represented by dots. So I could just draw a graph like that looks like a triangle. Maybe I have something a little bit more complex like this. So this second graph I drew has 5 vertices, it has 5 dots, and it has 5 edges because there are 5 lines there. So we're going to talk about 3 kinds of graphs. A simple graph has no loops and no duplicate edges. So something like this would be a loop, so we don't want any of those. And something like this would be a duplicate edge. It's an edge that joins the same 2 vertices that are already joined. So in a simple graph, we don't have either of those 2 things. A multigraph allows those. May contain loops or duplicate edges. So a multigraph could look something like this. And then in a directed graph, we give each edge a direction. And so these different kinds of graphs are all useful in different situations. A simple graph, you might have some nodes that you want to join with just one single edge. And whatever situation you're modeling would be like that. But in a multigraph, maybe you have like 2 cities and you have multiple train routes between those 2 cities. That would be a multigraph. In a directed graph, maybe you have cities and the trains only travel in one direction. And so you put an arrow on that edge to tell you the direction that they're going. Okay, the degree is of a vertex. And this is the number of edges touching that vertex. And adjacent talks about 2 vertices. And we say 2 vertices are adjacent if there is an edge between them. So here's an example of a graph, and let's talk about some pieces of this graph. So the vertices, and we list these as a set, are 1, 2, 3, 4, 5, and 6. The edges, we also list these as a set, are 1, 2, because they join vertices 1 and 2, 1 and 5, 2 and 5, 2 and 3, 4 and 5, 3 and 4, and 4 and 6. Let's count and make sure. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is how we write the edge set. We could find the degree of every vertex. So the degree of vertex 1 is 2. There are 2 edges which touch vertex 1. The degree of vertex 4 is 3. There are 3 edges which touch vertex 4. So we could do this for each vertex. Vertex 3 has degree 2. There are 2 edges which touch it. Vertex 2 has degree 3, 3 edges touching it. Same with 5. Vertex 6 has degree 1. This is a simple graph. There are no arrows on the edges to tell us which direction they go in. There are no loops, and there are no multiple edges, duplicate edges. So some more properties of a graph. A graph is connected if each vertex is connected, is adjacent, can be reached to another vertex. So here is example of a connected graph. If you wanted to go from this vertex to that vertex, you could walk along a trail of edges and get there. Whereas this graph is not connected because this vertex is not touching that vertex. I can't walk along a trail of edges to get from those two vertices to one another. That's because, remember, when two edges cross, it doesn't mean that there's a vertex there. So you can't like change direction on that crossing. We have to have a vertex there, a dot there. Okay, a path is a set of edges which connects two vertices. So if you wanted to redefine a connected graph, every pair of vertices has a path, at least one, between them. So if I go back to this graph here, I would call this a path between the top right and bottom left vertices. A cycle is a path that starts and ends at the same vertex. So in this graph, this triangle here would be considered a cycle. A bridge is a vertex or edge that, when removed, disconnects the graph. So if we go back to this two triangle graph, this edge here in the middle, if I remove that edge, I would end up with two disconnected components. So that edge highlighted in blue there is considered a bridge. Trees and forests. So a tree is a connected graph that does not contain a cycle. So it has to be connected. A forest is a group of disconnected trees. So if you had a tree here, this is one tree, right? It's a forest with only one tree in it. But if I added some more trees over here, so this is a forest which has two trees in it.